Practical electronics, soldering, solder. There are two types of solder, lead-free and leaded. Lead-free solder is kept on the white reels, leaded on the red reels. Whilst legislation stops us from using leaded solder in products, we should always use it in prototypes because it flows more easily and makes soldering easier. Soldering irons. A range of possible soldering iron tips are available, including point tip and chisel tip. You should always attempt to use the largest tip possible for the work you're carrying out. This is because the heat isn't drawn away from the soldering iron and will result in a better joint. Tinning wires. This is the process of preparing a wire to either be soldered to another wire or placed onto a board. The first stage is to cut and twist the wire. Firstly, remove a section of insulation from the wire using wire strippers. Now twist the conductor to ensure you have a good, solid conducting core. The amount of conductor that should be exposed depends on the task to be performed and will be covered later. This is an example of how the conductor should look after twisting, and this is an example of a poorly twisted conductor with stray wires. The wire should now be placed in a clamp. You will often need to clamp wires and components when soldering to free up your hands, one for solder and one for the soldering iron. Before attempting any soldering, your soldering iron should always be cleaned. An unclean soldering iron will contain dark areas where things have burnt or dull brown solder lumps. If these are left on the soldering iron, the quality of the solder joint will be poor. To clean a soldering iron, simply wipe it in the metal pad with heat applied to the iron. Once cleaned, the tip should look shiny and clear of debris. When using solder, it should always be cut from a reel, not pulled. This will ensure that the end of the solder is clean and grease-free and will result in better joints. The wire is now ready to be tinned. Place a small blob of solder on the soldering iron and then place this on the underside of the conductor. This will cause the conductor to heat up. Now place the solder on top of the conductor. When the conductor is hot enough, the solder will melt, at which point draw both the solder and the soldering iron along the length of the conductor. Note that the solder was placed directly onto the conductor and not onto the tip of the soldering iron. The tinned wire should now look like this. Note the area directly next to the insulator is not soldered. This ensures the insulator is not damaged and the cable remains flexible. To solder a wire to a PCB, we would first tin a section of wire and place it through a hole so it appeared on the underside of the PCB. As with all soldering, we would need to clean the soldering iron tip and cut a clean section of solder. We then add a small blob of solder to the soldering iron and place the soldering iron in contact with both the tinned wire and the pad. We then apply solder to the pad and to the wire, but not to the soldering iron. As soon as the conductor and the pad are hot enough, the solder flows and the joint is made. Watching that again in slow motion, the soldering iron is placed in contact with both the tinned wire and the pad on the PCB. When the solder is applied, it does not contact the soldering iron, only the pad and the tinned wire. Once both become hot enough, the solder flows and the joint is made. Also note, the solder is removed before the soldering iron. Finally, the excess wire is clipped. Be careful not to clip too much wire and damage the soldered joint. When soldering a component, you first need to pre-bend the leads to ensure that they can fit through the holes on the board. Note you should not bend the leads directly next to the component. This can cause fracturing within the component if you're not careful. Always leave a gap between the edge of the component and the location of the bend. Now place the leads into the holes on the board, ensuring that the component sits flush to the PCB. The process of soldering the component to the board is very similar to that for the tinned wire. Firstly, the soldering iron must be cleaned and a section of solder cut. Now a small blob of solder is applied to the soldering iron tip, which is then placed in contact with both the pad and the leg of the component. The solder is then applied to the pad and the component leg, but not the soldering iron, and as adequate heat is made, the joint flows. Finally, the solder is removed and then the soldering iron. The soldering iron is then cleaned and a new blob of solder attached. Again, the iron is brought into contact with the pad and the component leg, the solder to the leg and the pad, and when sufficient heat applies, the joint flows. This image is an example of a good joint. The solder is clean and shiny, and the hole around the leg has been filled. If too much solder is used, you will end up with a ball around the leg of the component. If too little is used, you will be able to see the hole through which the leg is sitting. Joining cables can be achieved in one of two ways. We will first look at the twist joint. Firstly, we will expose two identical lengths of conductor on the two cables to be joined. As with cable tinning, the conductor needs to be twisted to ensure it has a solid core. This is repeated for the second cable. Once the two cables are cut, they are placed side by side and the two exposed conductors are twisted together. Again, it should be ensured you have a solid core with no stray conductor wires fraying out. For ease of handling, place the joined wires into a vise. Clean the soldering iron, cut a section of solder and add a small blob to the soldering iron tip. Once again, place this on the underside of the twisted pair. Now place the solder on top of the pair, not in direct contact with the soldering iron. Once the solder flows, draw both the iron and the solder along the length of the cable, ensuring that solder has flown between both cores. Take the pair of wires and straighten them out, folding back the soldered section on top of one of the wires. Now take a section of heat shrink and apply it over the joint. Ideally, around 1 centimetre of heat shrink should be added to each end of the joint. Now take the heat gun and apply to the heat shrink. Continuously rotate to ensure that you do not burn one section of the heat shrink, and heat is applied equally across the length of the heat shrink. Take care also not to apply too much heat and therefore damage the insulator on the cables. The second option for joining cables is to use a butt joint. This is more difficult to achieve, but also more professional. Firstly, you need to tin 2 pieces of wire as described in an earlier section. As with any soldering, you need to clean the soldering iron and to cut a clean section of solder for use in the soldering process. Now add a small ball of solder onto the end of the soldering iron tip. Then place the tip underneath the section of cable held in the vise. Now place the second section of copper hard up against the first section so that they align perfectly and are parallel to each other. Once solder flows, draw the soldering iron along the length of the joint and then remove. The solder will now begin to cool. It is essential that the joint is kept still whilst this cooling occurs. As before, place a section of heat shrink over the joint, ensuring approximately 1 centimetre either side of the joint is added. Now use the heat gun to apply heat equally across the length of the heat shrink, also ensuring that you do not apply too much direct heat to the insulator, thus damaging it.